Hello everyone, welcome to our YouTube channel Physics Infinity. In our series of Fourier analysis, our next article is the analysis of rectangular or square wave. So let us define the function y. From time 0 to t by 2, the value of y is plus a, and from time t by 2 to t, the value of function y is minus a, as it is shown in the diagram. From 0 to t by 2, the value of y is plus a, and from t by 2 to t, the value of function is minus a. Okay? Now the Fourier series for this y is a naught plus summation n1 to infinity an cos n omega t plus summation n1 to infinity bn sin n omega t. Now we will find the values of these Fourier coefficients, that is a naught, an and bn. Now by definition, value of a naught is 1 upon t complete time period 0 to t f omega t dt, or 1 upon t 0 to t our function is y dt. Now we have a break in the function y at point t by 2. The value of y from 0 to t by 2 is plus a, and from t by 2 to t it is minus a. Therefore, there will be a break in the integration as well, from 0 to t by 2 and t by 2 to t. So just put the values of y in these intervals. From 0 to t by 2, y की value हमारी a. From t by 2 to t, this is minus a. Now this a is a constant and can be taken outside the integration. Here we have a upon t. Now integration of 1 is t from 0 to t by 2, the same limits, minus taken outside. Again integration of 1 is t, limits t by 2 to t. Putting the limits here and upon calculations, the value of a naught is equal to 0. That is, the very first term of this Fourier series is absent in this Fourier series of function y. Now our next Fourier coefficient an, by definition this is equal to 2 upon t 0 to t y cos n omega t dt. Now again the break of limits in the integration 0 to t by 2 and t by 2 to t. Using the value of function y in both the integrations, we have these two integrations. The very first one is 0 to t by 2 a cos n omega t dt. The second one is t by 2 to t minus a cos n omega t dt. Now taking out this constant a outside the integration, we get 2a upon t. Again this minus can be taken outside the integration. Now this integration is same here except the limits. Okay, integration of cos is sine, therefore integration of cos n omega t will be sine n omega t upon n omega between the limits 0 to t by 2, minus again sine n omega t upon n omega t by 2 to t. लिमिट्स पुट करते हैं यहाँ पर. 1 upon n omega from both the terms can be taken outside as a common term. Here we have, and using the limits here, sine n omega की value 2 pi by t into t, that is capital upper limit t by 2 minus the lower limit sine 0. This minus as it is. Now sine n 2 pi by t omega into this t, the upper limit, that is t here, minus the lower limit, that is t by 2. Now we know that sine of n pi is always equal to 0, whatever be the value of n, only the n should be an integer value. In all the four these, we have n as an integer value, and therefore all the four values will be equal to 0 here. That is, the value of Fourier coefficient an is also equal to 0. Now since an is 0, therefore the cosine term of the Fourier series are completely disappeared. That is, there is no cosine term in the Fourier series. Now the last one, the Fourier coefficient bn, by definition this is 2 upon t 0 to t y sine n omega t dt. Again the break of limits 0 to t by 2 and t by 2 to t. The value of the function y a taken outside, and from here minus a, this minus and this a. Again the integration of sine n omega t is minus cos of n omega t upon n omega between the limits 0 to t by 2 and here between the limits t by 2 to t. again this 1 upon n omega can be taken outside the integration. This 1 upon n omega can be taken outside here, and we have minus as it is the upper limits cos of n into 2 pi by t into the upper limit t by 2 minus the lower limit cos of 0. This माइनस एक यहाँ पर है, एक माइनस आएगा, इंटीग्रेशन ऑफ साइन, therefore 2 minus will become a plus, therefore here we have a positive sign here, and here the upper limit cos of n into 2 pi by t into the upper limit t minus the lower limit t by 2. Here we have upon calculations this term 2a upon t as it is and as it is, and in place of omega we can put 2 pi by t. This 2 can cancel out this 2 and t cancel out this t, and we get a upon n pi here. Okay, this is a constant term here. Inside the bracket we have 2 cancel out 2 and cancels out n, and we get minus bahar cos of n pi minus cos of 0 is equal to 1. This plus as it is bracket start cos of 2n pi minus cos of n pi here. Okay, this bracket close here. Now cos of 2n pi is equal to minus 1 raised to power 2n, that is an even power of minus 1, that is equal to 1. Therefore we have in place of this cos of 2n pi we have 1 here. This 1 as it is minus minus plus 1. This minus cos n pi and minus cos n pi will be minus 2 cos n pi. Now cos n pi is equal to minus 1 raised to power n. Using the value here we get this thing taken out. Take out 2 as a constant, 2a upon n pi. In the bracket we have minus of minus 1 raised to power n plus 1. Now there can be two possible values of n. n can be an even value or an odd value. अगर n की वैल्यू इवन है तो यहाँ पर क्या आ जाएगा, माइनस 1 रेज टू पावर इवन दैट इज 1, दिस माइनस दैट इज minus 1 plus 1 will be 0, and if n is odd we get here minus 1, this minus this will be plus 1, and this will be plus 1 plus 1, that is equal to plus 2 here. That is, for n is equal to even, the value of bn is equal to 0, and for n is equal to odd, the value of bn is 2 into 2, this is equal to 4a upon n pi. So this is the value of bn for n is equal to odd values only. Hence the Fourier series representing the exact rectangular wave with no constant term is what? A naught हमारा 0 है, a n हमारा 0 है, and in the values of bn for the even values of n, bn is also equal to 0. Only the odd values for the bn exist here. Therefore we have n is equal to 1 के लिए हमारे पास वैल्यू होगी, यहाँ से हम लोग क्या निकाल सकते हैं, 4a upon pi कॉन्स्टेंट दे सकते हैं. ठीक है, इन जनरल लिखते हैं 4a upon pi for n is equal to 1 sin 1 omega t plus for n is equal to 2 this is equal to 0 plus n is equal to 3 के लिए again 4a upon 3 pi sin 3 omega t plus n is equal to 4 again 0, n is equal to 5, we have from here 4a upon 5 pi this into sin 5 omega t and so on. Take out this 4a upon pi constant from all the terms. Here we have 4a upon pi common, in the bracket sin omega t upon 1 plus sin 3 omega t upon 3 plus sin 5 omega t upon 5 and so on. So this is the Fourier series for the rectangular wave. Here we have no any constant term here. The first three constituents of the series are, first one is this sin omega t into 4a upon pi, second is sin 3 omega t upon 3 into 4a upon pi, and the third one is sin 5 omega t into 4a upon 5 pi. These are the first three coefficients constituents of the series. Now here by comparing these three we get that they decrease in the ratio. Here we have 1, here we have 3, and here we have 5 in the denominator. That is, their amplitudes decrease in the ratio 1 by 3 ratio 1 by 5. And the frequencies, here we have 1 omega t, here we have 3 omega t, here we have 5 omega t. That is, the frequencies increase in the ratio 1 ratio 3 ratio 5. This is same for all the constituents. अगर हम लोग यहाँ पर और भी टर्म्स ले लेते हैं तो उनके लिए भी हमारे पास ऐसे ही रेशो आ जाएगी. So all the constituents have same phase. Here we have no any extra term in the angle in the sine. That is the all the constituents have same phase here. So this is the Fourier series for the rectangular wave. Here we have no any constant term, no any cosine term, only the sine terms are here, and that also with the odd values of n, and with the n even values of n the terms are 0 again. So this is it about it. Thanks for watching my videos. Keep watching. Thank you.